So today I want to start talking a little bit more about algorithms. So an algorithm is basically a finite sequence of steps to solve a problem. So say we are looking for something. It could be that we are looking for the location of a particular number in an array. It could be that there could be a lot of scenarios. I could search for a particular person that would fit a particular criteria. So this is a search problem. So I'm just going to describe a search problem here, right? Say we have the problem where we want to find the phone number of a certain someone called Kwesi. Kwesi is my friend. And we have a phone book with our contact in it. So we have the name and a phone number associated with that particular name in a particular book that we have, right? And we want to find the phone number of Kwesi. Solution 1 would be to basically open the book, flip the pages. I mean, you'd have to still read what's on the page before you flip it, right? So basically, I think you get me. Open the book and then read the numbers from the beginning until we find Kwesi. So that's one way, right? We basically open up the book and we start reading the numbers. I mean, the names associated with the numbers until we find the one we are looking for, which is Kwesi. If we find it, then we basically, we have the number that we are looking for. If we don't find it, then if we don't find it and we end up finishing up with the book and we still don't find it, we can assume that the person does not exist in we don't have Kwesi's contact essentially. That's one way to do it, right? But then I think we all have been in a situation where we are asked to search for a word in a dictionary. This is a similar problem where we are searching for a word in a number of words, essentially, right? And one thing that you do is that if you ask to search for the word, maybe congest, you would open to you try and open the dictionary, and if you open the dictionary and you see maybe K, you just open the dictionary in the middle and you see K, you sort of know that C is before K, and so you would try to open the dictionary to the left side of wherever you have opened at that moment, right? And in this case, we are able to do this because the dictionary that we have, we know the order in which the letters are in the dictionary. So we know that the letters are from A and they end on Z. So if I open the dictionary and I, reach a particular letter, I know which direction to go in order to find the letter that I'm interested in, right? And these are all ways that we sort of try and search for things in a group of things that we have, right? And these are all search problems. And as humans, we are able to find solution to this easily because our brain is sort of very intelligent. When it comes to computers, right? Computers are dumb, essentially. They can't actually just do these things that we do that we think are normal. So it's sort of you have to explicitly give the computer every single step that it needs to find that thing, right? So I'm going to go back to the search problem, right? And then in this case, let's consider a situation where we are trying to look for a number within an array of numbers. And let's say we are looking for the number 4. We are looking for the position of the number 4. These are the indices that we have for this particular array that we have over here. So our problem is that we want to know the location of 2, right? One thing that we could do is to basically go across all of this array, right? So we could go through all of them. So we go to 1, is that 2? No. Then we go to the next one, is that 2? No. 3 is not 2. Then we go to the next one, then we'll be is 4 2? No. And 5 2? No. Then we know that, we reached 2 and we realize that, 2 is the number that we are looking for and this is the index. So we can quickly say that, 4 is the index of 2 in this particular array that we have been given. In a, ideal world where this array that we have over here is sorted, one way that I could go ahead and find the number that I am looking for, the 2 that I am looking for, is by going straight to the middle of this array. Now, right now there are 6 elements, so I might not be able to find the exact middle, right? I could go straight to the middle of this array. I could go straight to 2 and check to see if the value that I am on is 2. I'll go straight to the middle of the array. And if this middle of the array is actually the value that I'm looking for, then I can basically return the index, at that instance, right? And in some situation, it might not be the case, but then because I know that the value might either be less than this middle value that I'm on or greater than this middle value that I'm on, I could either check the right side or check the left side, right? That's one thing that we could do. Turns out that this way of actually looking for numbers is an algorithm that is there. The algorithm that they refer to as binary search, So the first thing is that what? The array should, let me write it, it's capital letters, should be sorted. If it's not sorted, the algorithm wouldn't work, right? So say we have an array of, these are the indices that we have associated with this array. Say we are looking for the letter Q in this particular array. We know that these elements in the array are sorted. So the first thing that we can do is that, okay, we can check the middle of the array, which is 5. And this points to the letter I. Then we ask ourselves, because we know that this is sorted, we ask ourselves, the letter Q, should it be before I or after I? But then because we know the alphabet, starts from A and ends on Z, we know that Q should be after I. We sort of like now reduce our search scope. Instead of us having to go through the entire array to find the thing, we can go ahead and reduce this search array to somewhere from 6 to 10, because we know that the value is not at index 5, because we know that it's not I, and we also know that the value is not going to be anything before I, because we know that the array is sorted. So now we sort of like reduce our search space to between 6 and 10, and then we can do the same thing that we did, go ahead and look for the middle point of this 6 and 10, which is 8, right? And then we ask ourselves, what's the value at 8, right? The value at 8 is what? R. And we ask ourselves, is Q supposed to be before R or Q supposed to be after R? Looking at what we have, we know that it's alphabetically arranged, from A to Z. So we know that, okay, Q should be before R. So we are going to go ahead and reduce our search space to somewhere less than the 8, because we already know that it's not equal to 8. We're going to reduce our search space somewhere around here. Then we now ask ourselves, what's the midpoint between the two of them? Here it's going to be a bit tricky, so you can just choose any of them. But then usually, most of the algorithms will choose the lower one and go ahead with that. So if you take the midpoint of that would be 6. You ask yourself, what's the value at 6, which is J? Then you ask yourself, is Q supposed to come after that or before that? And then you can also reduce this. And you realize that whilst you reduce this, it ends up just being one value here. And when you try to go ahead and then check for this, you can localize that. Okay, so now we have position 7. What's the value at position 7? It's Q. And because we have the value at position 7 to be Q, and which is what we are looking for, then we can return Q as the final array. So now if you wanted to implement this in a programming language, one thing that you could do is to go ahead and then have this thing called like a 2 pointers. You have one pointer here and you have one pointer here at the beginning, right? And the goal of these pointers is supposed to basically refer to your search space, right? So the first iteration, you are going to be searching between these 2 pointers, right? You have one pointer here and you have one pointer here. You could call it like the high and the low pointer. And then when you find a midpoint, then you can move this pointer to this location. And now your search space is between these two, right? And then when you find a midpoint, you can move this pointer back here. And then you can just move this pointer back here. And at the same time, they would end up pointing to the same thing. Just make sure that these pointers will actually go, there's no way that you're going to move this pointer beyond this. You would always move it to this point, because if it goes beyond this, then it means that you've not found your solution. I'll just write a Python code for that and we'll have a look at it. So in Python, we want to define a function called binary search. And what we want this to do is to take in a particular list or an array that we want to actually find the thing and then the item that we are looking for. Now, before we even start, say we have our array, the item that we are looking for. So first we go ahead and then define our pointers. So you do low equals 0. The high would be equal to, we know that the index starts from 0, so we find the length of the array and then you subtract 1 from it, and that would give you the last index in the array. And what we are going to basically do is to continue to do the movement of the pointers while the left one doesn't surpass the right one, while low is less than or equal to high. So now we basically go ahead and find a midpoint. Low plus high divided by 2, right? You just add the two of them and divide them by 2. So we can assume that our guess would be equal to the array indexed at the midpoint. Then we can start checking if it's equal to the item that we are looking for. If the guess is equal to the item that we are looking for, return the midpoint because we want the location. If guess is greater than the item that we are looking for, then it means that the item that we are looking for should be on the left side of the guess. So what we have to do is to move this upper bound to somewhere around here, not the mid-range, less than the mid-range, because it's already not equal to the mid-range. So we move it to the one less than the midpoint. We now go ahead and set our high pointer to be equal to what? Midpoint minus 1. Else, in a situation where the guess is rather less than the item, it means that the item is on the right side of the guess. So we need to search the low pointer, midpoint plus 1. After we are done doing this, we just have to wait for our while loop to finish running. So if we don't end up getting the guess before the while loop ends up running, then it means that the item is not in the array, and then we can go ahead to safely return maybe none or -1 or whatever it is that the people return. So now if I go ahead and then just try and run the binary search algorithm that we have on our array, and then I pass in the item, this should return some location for me, and I can go ahead and print the location location, or should I say index, and I go ahead and then print this and set the value of this to the location that's been written. And now if I go ahead and run this, it says that what the location or the index of this is 7. Now if I were to give a value that does not exist in this, so if I were to give like the value to be z here, and I go ahead and run this again, then it says that what the value is none because it doesn't find anything in there. And that's like a very basic implementation of binary search.